Hello everyone, so welcome to my channel. So in these videos, we will continue our materials about linear regression. In our previous videos, we already talked about how we can construct a linear regression line and how we can use the hypothesis test and also the confidence intervals to help us check our assumptions and also check about our estimator of the parameter beta 0 and beta 1 in the linear regression model. So in this video, we will continue our talk, but now we move to the correlations. So when we look at the linear regression, so actually this is a model or an equation to help us describe the relationship between two variables, y and x. And if the relationship is linear, then we can use the linear function to help us construct this model. Then because here we have two variables here, right? So this is a very smooth question is what is the correlation between these two variables? So in these videos, we will talk about these materials. And before that one, let us to review some materials about what is a correlation between two variables. So in our lectures about probabilities, we already talked about the meaning of mean, the variance, and the covariance. So for mean is a method for us to describe a weighted average of our values. And then for variance is a way for us to describe the spread of our data. And then covariance is if we have two variables, for example x and y, then this is a way to help us to know the relationship and the combined spread of these two variables. So here I wrote down the definition of the covariance between x and y. So from this definition, you can see we can use COVXY to denote it, or we use sigma sub XY to denote it. And this is, if we look at the thing inside our E and the parentheses here, we can find this is very similar to the definition of variance. So the only difference is instead of use the square of x minus mu x, so here actually we use the product of the two difference, x minus mu x and y minus mu y, inside our definition. And then of course the mu x and mu y is the mean of x and y respectively. So this is about the variance of the x and y. Then the correlation. So correlation is like, you can think this is a normalized or unified of the variance. So because here for the covariance, of course, this number can be any, very large. But if we want to say use this one to describe the relationship between x and y, what we want if we look at one parameter and then we can conclude, okay, this is very strong positive relationship or very strong negative relationship. In other words, if one of them is increasing, the other one will also increasing, or it will decreasing, or they have no relationship. So in this one, what we will have is we will use a correlation instead of the covariance. So the definition of the correlation looks like this. So here, of course, we can denote this by CORR, or we can denote this by rho, the Greek letter sub xy. So this is two ways to denote our correlation. And here the definition of this one is use our covariance between x and y to divide it our the product of the standard deviation of x and y. And of course, if we denoted the standard deviation of our x by sigma sub x, and for y is by sigma sub y, then we can use this second one, this equation, to denote it our definition. But if we use the variance like the Vxy to denote it the variance, then this means standard deviation is the square root of our variance, right? So that's why here we can also rewrite this denominator as a square root of the product of these two variance. So this is a way just reveal our knowledge of the correlation. And then what's the materials we want to talk about in the linear regression. So in linear regression, we're always interested in the value of our beta 0 and beta 1, right? So when we construct a linear regression, we always interested in, is this a linear relationship between x and y? We use the hypothesis test to help us do this. And then when we get the value of beta 0 and beta 1, we want to know what is the true value of it, or what's the estimator of this beta 0 and beta 1. So here in this one, what we will have is, in fact, by beta 0 and beta 1, we have a equation of beta 0 and beta 1 with respect to our mean and variance, standard deviation, and also the correlation of x and y. So of course here again I will skip all the computing process, but if you're interested, just leave comments and maybe I will upload a video in the future to talk about this. So for the first about the beta 0, so the equation is look like this. So here in this equation, of course, we have mu x, mu y is the mean of our x and y respect here. And then for the sigma x, sigma y is a standard deviation of x and y respectively. And then of course here rho, I just use this one without any sub notation. So this is a correlation. And then here we have this is our equation for beta 0. And then for our beta 1, we also have an equation. And this is actually much simple compared to the beta 0. So for the beta 1, this is our sigma y divided by sigma x and times rho. So this is our equation for the beta 1. So now if we have this two equations, our beta 0 and beta 1, then what next thing? So here for mean, we know if we want to compute this one, we can think about use the sample mean. So like if we have several pair of the data for x and y, so we can try to use the sample mean to use this one to replace our mean of x and mean of y. And similarly, we can use this one to compute our sigma x and sigma y. But then one more question is, how about the rho? So here rho is about the correlation. So that means here we want to find an estimator of our rho. So now let's talk about what is an estimator of our rho. So here about the estimation of or estimator of our rho. So of course, if we look at our definition of our rho, we find this is the definition of our correlation. So this is about the numerator is the covariance, and the denominator is a product of the standard deviation. So what we can have here, in fact, this means we can just use our data to compute this covariance, to compute this standard deviation. And then we can just plug in this to the numerator and denominator, and that is our estimator of our rho. So here, the estimator of our rho, in general, we denote this by R. So for this one, the equation is, so this is the equation for our R, the estimator of rho, the correlation. So here in the numerator, you can see this actually is a way we can, if we change all the x and y to one symbol, like O to x, so this will be the sum of the square of xi minus x bar. So it's a way to compute the sample variance of x. In other words, if we change everything to y, then it's to compute our sample variance of y. And then in previous, we already say for the covariance, when we talk about the definition of covariance. So this is a way if we just change about here this x and y to one symbol, then this is same with for the variance. And here if we have the product of the difference for x and for y, then this is a variance. So the idea for here we use this similar idea is we just change the formula to compute the sample variance and change it as a square of one difference, one symbol's difference. So here we change the product of the difference of the two variables. And then for the denominator, if you look at the product inside our square root symbol, so you can see this is just the product of our sample variance. So that means here, in fact, you don't need to remember this equation. You only need to remember the formula for how to compute our sample variance, and then every other thing is very smooth. And of course, in the previous videos, we already have some symbol for this numerator and denominator. So for the numerator, this is s sub xy, and the denominator for the first term, this is s sub double x, and then for the second term is our s sub t. Okay, so this is just another way to denote this. So here, this is about our estimator for rho. So if we have this estimator for our rho, then let us look at our estimator of our beta 1. So in our videos about how we can construct a linear regression model, we already say the estimator of our beta 1 is s sub xy divided by s sub double x. So here, if we rewrite this one, so what we can do is we can here times the square root of our ss sub t to here. So what we can have, we will have this look like this. And then if here we just rewrite this equation, so what we will do is we will rewrite this denominator here of our s sub xx to two parts. So here this means for our s sub xx, we can rewrite this as the square of the square root, right? So then our equation will look like this. So then just group by the term about our s sub xy, and the denominator is a square root of s sub double x and double st. Then we will have this equation will look like this one. So what this means, so if you compare this term, the first term here, you can find this is just our estimator of r. So then what this means is we can rewrite this as our r times square root of sst and divided by s double x. So this is a way like how we can rewrite our estimator of beta 1. So we have two ways to write this. So the first one is we can write this as beta 1 hat is equal as numerator is sxy, the denominator is s double x. And then another way is we can write this as r times this square root. Okay, so then here let me use this is 1. And then if we want to compute the value of our r, what we can do is the first step is to compute the s sub xy and then compute s sub xx and compute double st, the sum of square t. Then we can get the answer. And if you compute this one, so in our previous video, we have an estimator of our r squared. So in fact, we have this relationship. Our r, the estimator of our rho correlation, is equal to the square root of our r squared. And r squared, we already introduced this one in our previous video. So in fact, this is a coefficient of our determination. So here I won't talk more about this R squared term, but if you're interested in it, you can find this in my video about the assumptions of the linear regression model. So this is the end of this video, and in next videos we will continue our talk in the statistics. So please subscribe my channel, and see you in my next video.